This is 10.1 number 2 from Math 127 OE1, the Lumen book that we're using. And when I first saw this looks a lot like a problem I saw for another book, and I'll show at the end how to do this using that formula. But it's the Surveyor's formula. But let me go through this. To estimate the height of a mountain, two students find the angle of elevation from a point at ground level. So B is 640 feet. So this is 640 meters, excuse me, from the base of the mountain to the top of the angle is 52 degrees. And then for A, this distance is 2350. The angle is 31 degrees. And we're going to go with the ground is level. And we want to find the height here. This is our target here. And one way to do this is to look at this in terms of, if you notice that we have this triangle like so, that bigger triangle, that if we can find this hypotenuse, let me call that the hypotenuse, then we would have this angle, this hypotenuse, and this opposite side, and we can use a sine function to find what the height is going to be. So that's part of the goal, is to find out what this hypotenuse is going to be. And so we can go with this law of sines that I have written down here that hopefully you've covered in the book. I know it's covered in the book at this point, but hopefully you've seen that. So a couple things. Let's find out what this angle here is going to be. And let me see if I can erase stuff. We'll erase. Okay. So first thing we'll do is we'll focus on this triangle here. And we want to find that hypotenuse. So if this is 52 degrees there, then 180 minus 52, it's going to borrow there, that becomes a 7, it's a 10, 8, 2, 128 degrees, right? So this is 128 degrees. So what else do we know? We want to find this other angle up here, because we know this side down here. So I don't know what to call that. Let's just call it theta for lack of anything else. We'll say theta equals 180 degrees minus 31 degrees and minus the 128 degrees. And what do we get for that? I'm just going to jump to my handy dandy calculator for this. Dead air time. Okay, I get 21 degrees. So this will be 21 degrees. So that angle is opposite this side, and we want this side over here. It's opposite this angle there. So we will do sine of, let me put the hypotenuse to the side length on top. The hypotenuse length over sine of 128 degrees equals the 2350 over sine of 21 degrees. So our hypotenuse, if I multiply both sides by sine of 128 degrees, and I want to be clear, someone's probably yelling at the computer right now as they're watching this. I know this is not the hypotenuse of the highlighted triangle. That's the hypotenuse of the bigger triangle. I'm just going to call it hypotenuse, so I'm not calling it multiple things. So it'll be, when I deal with this bigger triangle, that's going to include this and the rest of that. That's the hypotenuse. So clear that off for the moment. And what do we get here? Make sure my calculator's in degree mode. I got 2350 times sine of 128 divided by sine of 21. And I get HYP to be 5167.38529. Now, my calculator stores more than that. but that helps for now. So now what we're looking at is that bigger triangle that we have. This angle down here is 31 degrees. This is a right angle. That's for the height. And this was the 5167.3859. And so what it relates this is sine. So sine of 31 degrees is h over 5167.38529. So our h would be 5167.38529 times sine of 31 degrees. So what is that h going to be? And I'm just going to keep that stored value in my calculator and multiply that by sine of 31. I come up with 2661.400172. And so they took it further than I did, but that's the correct answer. Okay. Now let me show you another way of doing that same problem. Oh, by the way, just to recap, we are trying to find the whole thing. We're trying to find this height over here. This height here. Let me erase those. We're trying to find this height. So, and we're dealing ultimately with this triangle there. But what we do in the interim is we get rid of this and here. We look at the smaller triangle there. And we find our the big side. So we find the angles in the big side. Let me show you another way of doing this problem. And it comes from another book, and it's called the Surveyor's tool. So if you have a formula like this, if you have this kind of a drawing, alpha and that's beta, there's the height, and you have this distance here, so you have that distance there, you have this angle and this angle, you can do the height is this distance d, this right here, over cotangent of alpha minus cotangent of beta. And so when I put this in my calculator, it's my calculator, the one I'm using here, I know some of yours might be a little more fancy than this, but mine does not have a cotangent button, so I just use 1 over tangent. So I did h equals the d that's given to us, which is 2350, divided by, and then I did 1 over tangent of 31 degrees minus 1 over tangent of 52 degrees. And then that gave me the same thing, which is 2661.400172. So that's using the Surveyor's tool, which is, when I first saw this, I assumed that's how we're supposed to do it, but I was looking at some other things that they showed, and I think they want us to use loft signs. But now you have 2 tools, so hopefully that's helpful.